Welcome back. So we've already seen this code that I'm showing right now. It's what we used in the previous exercise. So we are already in exercise 5 on variable mutation, sorry. So first, before we go ahead, let's talk a bit on some of these things we um, looked at. So we have this i32 we have over here representing an integer 32. Now we said this age stores an integer 98. Ismail stores a boolean true and name stores a string Erekanye. So how does Rust know that this is a string, this is a boolean, and this is an integer? That's because Rust does type inference, where when you assign a value to a variable, it quickly checks what is the type of this value, i32. So we immediately make this variable an i32. What's the type of this? Boolean. Make this boolean. However, you have the power in your hands to make this work the way you want. So let's introduce a new variable, height, and let's set that this height should be f32. And shall assign it a value 174.5. That's in centimeters. So now by saying f32, what are we saying? We are saying that it's a 32-bit floating point type defined in IAA. I don't know how to explain this, but if you can read this, you'll see that this type can represent the wide range of decimal numbers like this, and so on. So if you want to know more about a particular type in Rust, especially using VS Code, first of all, you should have this Rust analyzer, the Rust analyzer and other Rust instructions installed, but the Rust analyzer is important enough for you to do that. And anytime you need it, just hover on the type and you'll see a description of that type. Let's go to i32. You notice that if we introduce i32, the i32 type on this, VS Code no longer shows it for us. But now what we can do is you can see a description of the type. The 32-bit signed integer type. If you go to the string, the same thing. If you go to the boolean, the same thing. All we just need to do is set that we want this to be a boolean. Now when we have set it that way, Rust automatically or immediately sets that this variable can take only these types. But if you do not set it that way and you initialize a value to it like we did here, or you assign a value to it like we did here, Rust understands that this is an i32 and it immediately also states that no other type can be assigned to this. Now with that said, we may want to modify the contents of a variable. We have seen that age can be 98, but we really believe that my age is 98. Actually, I could say I'm 214 years old. So now how do we change that? Age should be 214. Right? We see that there's an immediate error here. Let's try to run this. If you also write your main function, you notice that there's a run/debug showing over the function. So instead of going to the terminal and typing cargo run, which I'm already sure you're comfortable with, just click on run up here. Let's look at the error, right? We say we have an unused variable height and we have an actual error here, cannot assign twice to an immutable variable age. First assignment to age is on line 2. So we have line 2, age is 98, and help consider making this binding mutable, mute age. Cannot assign twice to immutable variable. That's all confused talk. It's the computer talking to us. But let me explain to you. Age here is immutable. We cannot change it. That's what immutable means. So anytime you create any variable in Rust without specifying that you want it to be mutable, Rust understands that it is immutable, it cannot be changed. So there's no other value you can assign to it apart from the one you assigned first. So this can never have any value again except 98. But we don't want that. What we want to do is be able to change the value of age. So what do? You simply make age become mutable by putting another keyword, mute. What does mute say? Mute says that this variable is a mutable variable, is a mutable variable, or mute can modify a reference or a pointer to make it in such a way we can change. Mute can be used in several situations. The first is mutable variables, which can be used. used. Anywhere you can bind a value to a variable name. Some examples: 1 is a mutable variable, 2 is a mutable variable, 3 is a mutable variable, 4 is a mutable variable, 5 is a mutable variable, 6 is a mutable variable, 7 is a mutable variable, 8 is a mutable variable, 9 is a mutable variable, 10 is a mutable variable, 11 is a mutable variable, 12 is a mutable variable, 13 is a mutable variable, 14 is a mutable variable, 15 is a mutable variable, 16 is a mutable variable, 17 is a mutable variable, 18 is a mutable variable, 19 is a mutable variable, 20 is a mutable variable, 21 is a mutable variable, 22 is a mutable variable, 23 is a mutable variable, 24 is a mutable variable, 25 is a mutable variable, 26 is a mutable variable, 27 is a mutable variable, 28 is a mutable variable, 29 is a mutable variable, 30 is a mutable variable, 31 is a mutable variable, 32 is a mutable variable, An example we have here is setting the value of age to 98 and coming down here and setting it to 214. So down here we now see that we have changed the value of age safely. Let's now run the code. Age shows 214 instead of 98 we initially assigned to it. Now we've introduced one thing. We have been able to mutate a variable. We also see that we can mutate the value of height. But before we do that, let's try to use height so it stops complaining, right? Height should be equal to, I'll just give here. Now let's run. Okay, so if we look at this, we say height is equal to 174.54. I think there's something I'm missing out. Yes, print line statement. All right. Now we said there's another warning that comes here from Rust. I wanted to isolate this warning so you can see it clearly. Value assigned to age is never read. What did we say when we were defining Rust? Rust is a language that emphasizes a lot on memory and safety. Safety, memory, these are very important constructs in Rust. So we don't just assign a value to a variable and never use it. That's what Rust is telling us. We have never read this before, so why assign it? Rust is going to give us a lot of warnings most of the time when we do these kinds of things. So we know that age is already assigned 214. So what we could simply just do is remove this declaration we have here. And what you now realize is they tell us, if we run this program, they tell us variable does not need to be mutable. So this is Rust introducing another warning to us. If we have not modified the value of a variable, why make it mutable? So we then see that the very definition of Rust we have been talking about actually comes into play in simple situations like this. First, you don't say mute and then you don't use a value you've already assigned. Use it. If not, don't assign it. If you have assigned the value just once, then why make it mute? So if you want to allow this to be valid, if you want a program to be valid, let's remove this first and let's write here old age should be equal to this, and let's come below and say age equals 214, then print line new age should be equal to age, right? Now I'm running the program. Perfect, no errors. Old age 98, new age 214. So that way we have used both values that have been stored in each. But this does not mean you have to go the long way making sure you've used every variable, every value you've created, or every value you've assigned. It's simple. If you don't need to use a value, do not assign it, do not introduce it to your compiler, because unnecessary. These are actually things allowed in other programming languages, where Rust clearly makes sure that it doesn't allow it. So with that said, we have seen how we can mutate a variable. Mutation means change, allowing it to change. So we can now say confidently that if we have not introduced the mute keyword to a variable, we could call it a constant, right? Because it never changes. But let's not go there. Let's just call it an immutable variable, while the ones with the mute keyword are mutable variables. Thank you very much, guys. See you in the next video.